So we're looking at mixed exercise 5 from the first year core textbook, and we are, so that's on straight line graphs, and we're on the last question. So it looks a bit different to the rest of them. So first glance, it might be a bit off-putting, but actually each part is only worth 1 or 2 marks. So it shouldn't be anything too bad. It's an exam question. And they're just introducing more of these real life questions. Doesn't mean they're any harder, just means they, as I said, they look a little different. Okay, so use 2 points on the line to calculate its gradient. So obviously this is the line of best fit. It's not going through all these coordinates. So you don't need to find 2 of the crosses. It's this straight line that we're looking at. So the only reason that the crosses are relevant is it sort of tells us how good a line of best fit this is. So whenever you're working out, if you're actually calculating a gradient, and you're having to do it from the line, you want to try and get 2 coordinates as far away as possible. So I'm going to go right to the end here, and it is a bit hard to see, unfortunately I can't zoom in, but I think that is 2 small squares below the 1,000, and each little square is worth 50. So I'm going to say that far end is at the coordinate 900, 0. Okay, then I'm going to try and read one up here, and I think my eyesight's not failing me, that there, if I go up, if I go to, well, it's not X, is it? I think it's P, but if I go to 4,500 on the horizontal axis, I get that to be one, I was doing this earlier, and I think if I trace along, I get that to be 1 small square above 35,000, and each small square on that scale is worth 1,000, so that would make it 36,000. I think as accurate as I can read it, that's what I would get. So the gradient is changing Y, or changing the T, I think, is it? No, changing C for this one. So 36,000 minus 0 over 4,500 minus 900. So that is 36,000 over 3. Well, at least it gives us a nice round answer. So that would give me a gradient of 10. Okay. Formulate a linear model linking oil production P and carbon emission C. So this is just the equivalent, you've seen it a lot already in this exercise. They're basically just asking you to find the equation of a straight line. And I know the gradient is 10. And all I therefore need is a coordinate. It goes through, I think, of my 2 coordinates, I was probably slightly more confident about the accuracy of that one. So I'm going to use that as my coordinate. So normally we'd be using y minus y1 is m times x minus x1. But of course it's not y and x, it's P and C. So P is the oil production. So oil production is my x values, and C is oil carbon dioxide emissions, and that's what's on my y-axis. You could do this part of it still in terms of x and y and then just change it at the end, but you won't generally for this type of question when they've come up before. If you accidentally leave it in terms of x and y, you won't get anything. Okay, so that's, let's see, my gradient. That's my y, or in this instance, C coordinate, and that's my x, or in this case, P coordinate. So C minus 0 is 10 times P minus 900. So obviously C minus 0 is just C. That's going to become 10P minus 9,000. But we can have a look back at the graph and see if that seems plausible. So we already worked out the gradient was 10, and it's definitely a positive gradient. And yeah, looking at that scale, I think if I were to carry that on, a y-intercept of minus 9,000, yeah, I think as far as I can judge, it's about right. Okay, so then I've got to interpret the value of A, and A is the gradient. So obviously, so it's 10, but interpret, I need to relate it back to real life value here. And actually, this comes up quite a lot in stats when you're so when you do stats next year, if you haven't done it already, you have to interpret your regression line. So what I would just say, so basically they're asking us to interpret what that 10 is. So for every, so every time P goes up by 1, C goes up by 10. That's the significance of the gradient. But I need to think about what the actual scale is. So the P-axis is in million tons. So for every 1 million ton increase in oil production, in oil production. So you can just, I don't really think I should have a capital P or a capital A, actually, should it? So you don't have to have any kind of knowledge of these situations they're describing. You can just copy it sort of straight from the question. So for every time this goes up by 1, and that's representing a 1 million ton increase in oil production. The Y value, which is carbon monoxide emissions, monoxide or dioxide? Dioxide. The carbon. See, I said you didn't have to have any kind of knowledge. So the carbon dioxide emissions increase. So they're increasing by 10. The gradient is 10, but again, this is in millions of tons. So the carbon monoxide increase by 10 million tons. I mean, it would also hold, I guess, therefore, that for every 1 ton, for every 1 ton increase in oil production, the carbon dioxide increases by 1 ton. Should that have an S on it for every 1 million? Yeah, it should be for every 1 million tons. So for every 1 million tons increase in oil production, the carbon dioxide emissions will increase by 10 million tons. Okay. But like I said, you'll actually do practice that quite a lot in stats. So with reference to your value of B, comment on the validity of the model for small values of P. Okay, so we can actually see, so this goes back to the coordinates they've given us. We can see that the lowest amount of oil production they recorded was about 2,400 tons. So they didn't get any data down here. And again, this idea will come up a lot in stats, and it's extrapolating. So basically what they're trying to get at is, yeah, that's fine. We've recorded a lot of data for sort of 2,500 to 4,000 tons, and it all looks like it's falling a nice straight line. But that pattern is not necessarily going to continue on. So we couldn't really, so we'd be extrapolating if we tried to make any predictions of when there was lower oil production. So it's unreliable, but then we can be more specific because they have asked us about our value of B, where our value of B would be saying that if there was no oil production, we'd get negative carbon dioxide emissions, which obviously is not possible. So let's just look at their answer for that. Save you watching me write the whole thing out, but with reference to your value of B. So our value of B is negative, which would mean that at 0, if there was no oil production, carbon dioxide emissions would be minus 9,000 million tons, which is not possible. Therefore, the model is not valid for small values of P. I imagine they've said it in a much more succinct way to that. Yeah, so not valid for small values of P. So you can't have negative emissions. The main issue people have with questions like this when they come up in the exam is being too vague. Okay, so make sure you're really clear why it's not feasible. So it's specifically because you could not have negative emissions. Okay, and yeah, we got 10. I think we got that. Let's just double check. Yeah, and what was the other part? Oil production increases by 1 million tons. Yeah, we're good.